you've got all your extra practice problems on Polaris too that you can use at home if you feel like you need to study or practice a little bit more. Part 2 is no calculator, period. Okay, so no graphing calculator, no red calculator. You guys remember solving all the equations with all the radians and stuff. There's not really a whole lot of calculator to do for you anyway, unless you have to do like an inverse sine, cosine, or something like that, which you don't have any of those problems on the test. Okay. And then you guys are going to get that same formula sheet you had yesterday. It has the only identities we're going to give you are the sum to product ones, where you change a sum into a product. You do have to know at least your fundamental identities, so your Pythagorean identities and your reciprocal ones. Those are going to come into play just in a couple little things in the equations, but no other identities on your sheet are even going to be used at all. You don't have to worry about those. Okay, so let's see if we can get through it. Find all solutions on the interval 0 to 2 pi. All right, what strategy could I use here? What would you do? Oh.
But 2 sine squared, like, is not a formula.
2 sine squared, if it was a -1, would be a double angle. But remember, we're not using any, you're going to make it more complicated if you use double angles. So just in general, if I have, this is called a quadratic form, right, where we have a squared term and one that's not squared and one that's a constant. If you have something that looks like a quadratic, what should be your first step? Before we factor it, before that. Yep. Everything on one side, you got to get equal to 0, and then we're going to factor it. All right, so I'm going to move the 1 over. And because all of my terms are sine, I don't have any, like, 2 different trig functions here, I don't need to worry about using an identity. And now we factor. Remember, if you get stuck on the factoring, you can use the quadratic formula. The quadratic formula will tell you what sine is equal to, but that you'll still need to find the angles in your unit circle. All right, so what should go in the front of my parentheses? 2 sine and what's going to go in front of the other parentheses? Sine. Yep, 2 sine and sine, give me 2 sine squared. Okay, that's going to be the front term. What's going to multiply together to get a -1 in the back? It's going to be a -1 and a +1. So really, the only guess and check part of this is where does the plus go and where does the minus go? We want to make sure that my middle term is a minus sign. So if you put the plus in the front and the minus in the back, what you want to check is your outside plus your inside terms. My outside terms would be -2 sine. My inside terms would be a 1 sine. And when I put those together, those give me negative sign. So just foiling at this point to make sure you have factored correctly, even if you do it mentally, is a good step. Once it's factored, set each factor equal to 0. Sine -1 equals 0. And then solve for sine. So sine equals -1/2. Sine equals 1. And then we want answers between 0 and 2 pi. So now is where our unit circle would be helpful. Where on our unit circle does sine equal -1/2? There should be 2 of them.
7 pi over 6. 11 pi.
Yep, and then where does sine equal 1? There's only one of those. Pi over 2, and those are our answers. Okay? Any questions?
How do you know the answers?
As in, like between 0 and 2 pi?
Yeah.
Because there's not any more of those sine values on our unit circle.
But I don't do it plus pi.
You can do plus pi k here, but I would just be attaching it to these answers. When you find your answer on the unit circle is where you put the plus 2 pi k in. So I could right now say plus 2 pi k, but then I want answers between 0 and 2 pi. So the plus 2 pi k isn't going to give me any additional answers because it's going to put me over that plus 2 pi. So if you want to, you can put it in there. And if the problem said find all solutions, period, not in an interval, you'd want to include the plus 2 pi k. But because it's just that interval and because we're done at this point, we don't need that extra piece. Okay, we'll see some problems where you have to put it in and we'll talk about why you have to put it in the work. Okay, so let's look at this one. I want answers between 0 and 360. So final answers are going to be in degrees, but the rest of it's going to be pretty similar. This one's already equal to 0. Good. What do you notice, though? Two different functions. So we do have to use a Pythagorean identity. You need to know what sine squared is equal to. What's sine squared equal to? 1 minus cosine squared. That's pretty much the extent of a Pythagorean identity you would need to use. Okay? Just make sure you know all three of them. Could be a cotangent or a cosecant or something. All right, distribute my 2 in. 2 minus 2 cosine squared plus cosine minus 1. Combine my like terms, so I'll have a negative 2 cosine squared plus cosine, and then negative 1 and a positive 2 will give me a positive 1. And then if you remember when I did this, when we did the lesson, I talked about it like that first term to be positive. It's going to make it easier to factor. So I would just divide or multiply everything by negative 1. It's just going to switch all your signs. So to make it a 2 cosine squared minus cosine minus 1 equals 0. Okay. All right, so now does it factor? What goes in the front of the parentheses? 2 cosine and cosine. And actually, this is going to factor the same way as the last one, isn't it? Multiplies to negative 1, 1 and 1. Make the first term positive, the last one negative. My outside will be negative 2, my inside will be positive 1. I'm good. Set them equal to 0. Minus 1 equals 0. So cosine equals a negative 1/2, and cosine equals 1. So at this point, we find our answers on our unit circle. Remember, we are in degrees for this problem. Where in degrees does cosine equal negative 1/2?
120.
Yep. And then there's one more, 240. And then where does cosine equal 1? So it's 0 or 360 because they're in the same spot. So look up at the instructions. Which one are we equal to based on how it's written? 0, because it's a bracket at 0, parentheses at 360. So it tells us which one to use if you get stuck there. Okay? Questions on that? 1. Okay? Let's do this one. Find all solutions on the interval 0 to 2 pi. All right, now this type of problem where your angle is anything other than just a single variable, like an x or a theta, where it's something else, a 2x, an x divided by 3, and x minus pi over 6, where we have to replace the angle with something easier, is where in the work, you probably want to include the plus 2 pi k. Sometimes it won't make a difference. Actually, in this problem, it probably won't make a difference, but it occasionally can, and especially the ones that are like double angles or half angles, it will make a difference in how many answers you get, okay? All right, so I'm going to replace it with a theta first, and I'm going to solve the easier equation. So I'm going to get my tangent alone. If I get tangent alone, I'd have to add 1 and divide by 3, so 1 over rad 3. And I'm just going to leave it like that, and there should be 2 places on the unit circle where that occurs. Where does tangent equal 1 over rad 3? So remember, tangent's y over x. If I do a half divided by rad 3 over 2, that scenario is where I'm going to get the 1 over rad 3, right? So that's what I'm looking for. Pi over 6 is an answer. And where's the other one? 7 pi over 6. Okay, and like I said, if we are replacing the angle with something, we want to include plus the period times k in our work, even if we don't need it at the very end. So what's the period of tangent? Pi k plus pi k. All right, once I have theta solved for, we go back and replace my angle, x minus pi over 6. Pi over 6 plus pi k. X minus pi over 6 equals 7 pi over 6 plus pi k. And then to solve for both of these, I just need to add pi over 6 to get the x alone. And we're just adding together like terms. So you're just adding the pi over 6 and the pi over 6. What's pi over 6 plus pi over 6? 2 pi over 6, which reduces to pi over 3 plus pi k. And for the other one, 8 pi over 6, which reduces to 4 pi over 3 plus pi k. All right, so now my answers between 0 and 2 pi are pi over 3. And if I add pi to that, what do I get? 4 pi over 3. And if I add pi to that, I get 7 pi over 3, which is bigger than 2. And then you'll see, remember we talked about the tangent and cotangent ones, you just get those redundant answers. So I actually didn't need that second half, but that's okay. So in this case, if you didn't worry about the 7 pi over 6, that plus pi k would give you that answer. If you didn't have the plus pi k, but you accounted for both possibilities, you get both answers. So either way, you can't really go wrong with that. Okay. Any questions on that one? All right. Number 11. All right, they're different functions. That's not good. Neither one squared, so I can't use a Pythagorean identity. So what should we probably do? Square it. You got to make them squared to be able to replace one with the other. In this problem, I will tell you guys this and the very last problem with the sum and difference. These are the two most missed problems on the test. This is one of the most missed problems because people do this first step wrong. They just don't FOIL or distribute like they're supposed to with this squared. On the left, we are distributing that squared in because it's a product. I'm allowed to do that, okay, because they're multiplied together. So what's rad 3 squared? 3, and then cosine squared. On the right, make sure you are FOILing, okay? So many people, I cannot tell you, so many people do not FOIL when they do this. So if I FOIL out, it's 1 for my first terms. I'll have a negative sign and a negative sign, so minus 2 sine plus sine squared. If you've done this part right, you've set yourself up for success because the rest of it's now really similar to what we did with that other problem where we're going to replace cosine squared, because that's the guy that doesn't fit right now, with what it's equal to in the Pythagorean identity. What is it equal to? 1 minus sine squared. Okay. And then I'm going to distribute and get it all on one side here. So if I distribute, 3 minus 3 sine squared equals 1 minus 2 sine plus sine squared. Then I want to get it all equal to 0. I want my squared term to be positive, so I'm going to move everything over to the right. So that'll be 0 equals sine squared and 3 sine squared are going to give me a 4 sine squared. Then I'm going to have a negative 2 sine. And then I'm going to have 1 minus 3, which is going to give me a minus 2. And then everything there, this is an optional step, is divisible by 2. It's going to make my factoring easier. So I'm going to divide everything by 2 and make it 2 sine squared minus sine minus 1. And I actually think this is going to factor the same way as those other ones we did. It's going to be a 2 sine and a sine, and it's going to be a plus 1 and a minus 1. Keep getting that same quadratic over and over again. If I set them equal to 0, I get sine equals negative a half, and I get sine equals 1. And then solving, what are we looking at? We're looking at degrees, it says in the instructions. 0 to 360. Where does sine equal negative a half? In degrees?
Degrees, that was at 210.
210. And what was the other one? 330. And then where does sine equal 1? Cosine equals 1 there. 90. Remember, sines are y coordinate. Okay, we're almost done. So in these problems, where you square both sides is where we get extraneous solutions. So these are the ones, and this is really the only one you're going to see on the test where you could get extraneous solutions. It is vital that you plug your answer back in and make sure it works. So let's say I plug in 210. You don't have to show all the work for this, or unless you want to, you can. If I put 210 in, can you tell me what the cosine of 210 is if I plug it in the left side there? What's the cosine of 210?
Rad 3 over 2.
Negative rad 3 over 2. And if I multiply negative rad 3 over 2 times rad 3, what do I get? Negative 3 over 2. So if I plug 210 on the left, I get negative 3/2. If I plug 210 on the right, I would have to do the sine of 210. What's the sine of 210? Negative 1/2. And if I do 1 minus negative 1/2, I get 3 over 2. 1 minus negative 3/2, or negative 1/2, is positive 3/2. Does that check? Is that right? Does negative 3/2 equal positive 3/2? No, it does not. So 210 is extraneous. I'll tell you just for time's purposes, if you plug in 330, it works, and if you plug in 90, it works. And if you need to show how you're plugging it in, draw out all the steps, that's fine. But you want to make sure that you are checking those answers at least. Usually the places where we have extraneous solutions are in quadrant 2, 3, or 4. Things in quadrant 1 are always positive, so we don't have this plus minus situation in most of the cases when I plug in angles from quadrant 1. So if you are short on time, start with angles that are not in quadrant 1. Those are likely where the extraneous answers are. Yes?
Is this the only problem that could be extraneous?
This is the only one that's going to be extraneous. Yep. Where you square both sides. Because what happens when I square both sides is two opposite numbers like this, negative 3/2 and 3/2, are equal to each other when I square both sides. So it gives us this like false solution. Okay. All right. How many more problems we got? 1, 2, 3. You want to finish the other 3 tomorrow? Does that seem like a good stopping place? All right. If you want to try those 3 ahead of time tonight on your own, go for it. But that's planned for tomorrow. We'll just do those other 3. And then you guys are just going to study to get ready for Monday. Sound good? Great. Okay. All right, cell phone motto.